Let's have a look at a second example of combining inequations. So we've got the scenario. Arana and Rosa both own taxis and both charged fares to the nearest kilometre. So Arana charges no more than $15 base fee plus $2 per kilometre, and Rosa always charges $5 per kilometre. So we need to draw this on the graph and find the cheapest fares for distances up to 15 kilometres. Okay, so the first thing we need to do is define what our variables are. So if we look at what the costs that we've been told about, we're talking about a base fee plus $2 per kilometre. So there's a hint. So we need to know how many kilometres they are driving. Okay, so that's going to be one of our variables. So I'm going to call that K. I'm going to say K is the number of kilometres. Travelled. Okay, the other kind of information that we've been given is about costs. All of these other numbers are about costs. So that needs to be my second variable, is the cost. So I'm going to say C is the cost or fare of the trip. Okay, our next step is to find the inequations or equations. So let me just clear that off. Okay, so we want to look at each of these sentences and say, right, Arana, what do we know about Arana? She charges no more than. Now, no more than. So in inequalities, no more than means less than or equal to. So she charges no more than $15 base fee plus $2 per kilometre. So for if she went 1 kilometre, she'd charge $2. If she went 3 kilometres, she'd charge an extra $6. So I'm multiplying that by the number of kilometres. Okay, and so I can say the cost is going to be less than or equal to 15 plus 2k. Okay, now let's look at Rosa. Rosa always charges $5 per kilometre. So so her cost is always, so equals $5 per kilometre. So 5 times the number of kilometres. So there's our two equations. So let's have a look now at drawing this on a graph. So the first one has a less than or equal sign. So that means we need to draw that as a solid line. And the second equation is an equals to, so that's just going to be the line itself. Okay. So let's take the equation number 1. C is less than or equal to 15 plus 2k. So the number by itself, 15, is where it's going to cut our axis. Now we need to label which axis is which, so I'm going to put my cost on this axis and I'm going to put my number of kilometres on that axis. So I'm going to have an intercept at 15 and I've got a gradient of 2. So the number in front of the variable is 2. So that means I go up by 2, cross by 1. Now you just got to be aware that each of these boxes is steps of 5. So I'm going up in 15, 20, 25. So I'm going, each box is 5 wide. So I want to go up by 2, across by 1. Up by 2, cross by 1. Where am I? There, 21, 23, 25, and so on. Okay, now I need to draw that as a solid line. So I am going to grab my drawing tool and that is going to be about there. Now the inequality says less than. So look at where it cuts through the c-axis. So it cuts through there at 15. We want the values that are below that are less than that. So that means I need to shade out all the values above it. So I'm going to shade out that region above. Okay. Now let's look at the second equation. C is equal to 5k. So that's going to have an intercept, so I can always add plus 0 to anything. So that's going to have an intercept at 0. So there's my intercept. Gradient of 5 means I go up by 5, crossed by 1. Up by 5, crossed by 1, and so on. And I'm now going to draw that as a solid line. And that will go through about there. Okay. Now, I don't need to do any shading for this one because I'm only interested in the values on that line itself. So now what I need to do is identify which points, which are possible solutions to this. So I know that they can't be above the blue line. So the blue line or below is anything is possible. And it has to be on that, it has to be equal to that one there. So the question was, find the cheapest fares for up to distances of 15 kilometres. So what we've got is, if I look at the line here, we know from 0 kilometres through to 5 kilometres, the green line is the lowest. Yep. So that green line, that is Rosa. So I know for the first 5 kilometres, Rosa's fares will be the cheapest. After that, after 5 kilometres, so from 5 up to 15 kilometres, we know that the blue line has the lowest cost, and so that then means from 5 kilometres upwards that Arana's fares are cheaper. And that's what we want to write as our answer. So we're going to say for up to 5 kilometres, Rosa has the cheapest fares. And after this, Arana's fares are cheaper. And there's our answer.